h of x. We're going to find that by setting this to 0. So we'll have y double prime plus k squared y equals 0. So this is the first stage. Now the particular solution, we're going to need this minus cosine x in our calculations. So here we've got y double prime plus k squared y equals 0. Now separation of variables and integration is not going to give us the solution that we're going to need. So what we can do is we can use something called the characteristic equation. So the characteristic equation, I'm just going to write EQ for short. Now what that does, it works on how many derivatives y is taken as. So here we've got y double prime, so we'll write this as r squared. Now 2 is for the second derivative, so that's why we write r squared, and we substitute the y for the r. Here we've got k squared. Now our y here is not a derivative, it's just a function of y. So effectively we've got r to the 0, and that equals 0. Okay, now we know r to the 0 is just going to be 1. So that's just going to leave us with r squared plus k squared equals 0. Now for the characteristic equation we need to solve for r. So bring the k squared to the other side. So r squared equals minus k squared. So now we take the square root on both sides. And that's going to leave us, well, r squared, take the square root, that just leaves us with our r, which is what we want. Now here, we know that k squared is greater than 0. That's not going to be less than 0. So we know that this is actually a minus value inside the radical. So the minus k squared is going to leave us with plus or minus I times k. That's going to be our solution for this. So that's going to give us two solutions of complex value. So we have two solutions of complex value. So now